Today, we'll decode the modern periodic table by understanding families, blocks, metals, nonmetals, and metalloids. Let's start with families. In the periodic table, elements with similar chemical properties are grouped together and given family names. These names help us instantly recognize how an element behaves. Alkali metals group 1, 1A, elements of group 1, also called alkali metals, are highly reactive. They react strongly with water and form alkalis. For example, sodium reacts with water to form sodium hydroxide, a strong base. That's why these elements are called alkali metals. Alkaline earth metals group 2, 2A, elements of group 2 are known as alkaline earth metals. They are called earth metals because they occur in the Earth's crust, and alkaline because their oxides are basic in nature. These elements are less reactive than alkali metals but still very important chemically. Halogens, group 17, 7A, elements of group 17 are called halogens. The word halogen means salt former. These elements easily react with metals to form salts, for example, sodium chloride. They are highly reactive nonmetals. Noble gases group 18, 8A, elements of group 18 are called noble gases. They are the least reactive elements in the periodic table. Because they rarely form compounds, they are called noble, meaning inactive or stable. These family names make the periodic table easier to remember and understand. Now let's talk about blocks. The periodic table is divided into 4 blocks based on the valence orbital involved in chemical bonding. This classification helps us predict valency and oxidation states. Elements of group 1 and group 2 belong to the s block. Their valence electrons are present in the s orbital. These elements are highly reactive and mostly metals. Elements of groups 13 to 18, except helium, are called p block elements. Their valence electrons are present in the p orbital. This block contains metals, nonmetals, and metalloids, making it the most diverse block. The transition elements belong to the d block. Here, electrons in the d orbital are responsible for their valency. These elements show variable oxidation states and are widely used in industry. The lanthanides and actinides form the f block. Their valence electrons are present in the f orbital. These elements are placed separately at the bottom of the periodic table to keep it compact and readable. Another important way to classify elements is based on their metallic character. Most elements in the periodic table are metals. They are found on the left side, in the center, and at the bottom of the table. Metals are generally shiny, malleable, and good conductors of heat and electricity. Nonmetals are present mainly in the upper right corner of the periodic table. They are usually dull, brittle, and poor conductors. Examples include oxygen, nitrogen, and chlorine. Some elements show properties of both metals and nonmetals. These are called metalloids or semimetals. They are found along the stepped line in the periodic table. Examples include silicon, arsenic, and tellurium. These elements are extremely important in electronics and semiconductors. In the periodic table, elements of groups 4A to 8A, at the top right-hand corner above the stepped line, are nonmetals. The elements just under the steps such as silicon, arsenic, and tellurium, are the metalloids. All the remaining elements, except hydrogen, are metals. If this video helped you, like it, share it, and subscribe for more clear science.